Okay, so this is a recap of chapter 2 that I'm making for you guys, and I'm sorry this isn't going to be as organized as I usually like it, but time's been a little tight. Hopefully it's helpful. I'm just basically going to go through the review packet that I gave you guys and do some of the problems that I feel like are a little bit harder, or maybe just there's tricks in there that um, we just haven't seen too much of. So, first one, number one. This I did go over in class, but I want to go over it again. This is mostly going to happen in the calculator. So, um, if you see here, you have these this table with these dates and the populations. This is going to be your list 1, and this is going to be your list 2 in the calculator. So we turn on the calculator and we go over to stat, and then it gives us the option edit, and we have our list 1 and list 2. If you have data in the list, you go all the way to the very top and you hit clear and then enter, and it clears out that whole list. And we could do the same thing with list 1. Okay, now let me say something about these x values, because this is going to happen on a lot of problems where you could either enter the literal year 1990, 1991, 1992, 1993, or you could enter any set of numbers almost, as long as they are one digit apart and there's 7 of them. You know, like I could enter 1, 2, 3, 4, 5, 6, 7 like it has here, or another set of numbers. It's your choice. The issue is you're going to get a different equation, but it's still going to give you the right um, answer in the end. It should still give you the right answer. You're going to get different coefficients, but it should still give you the right answer in the end. So what I'm going to do is I'm going to say, well, they have here t equals 1, t equals 2, t equals 3. So these are what I'm going to enter in to my list 1. 1, 2, 3, 4, 5, 6, and 7. Go to list 2, and I put in 59,000, 48,000, 43,500, 49,000. Excuse me. Sorry if that scared you. 41,500, 39,000, 42,500. Okay, so now we have the data in the list. Great. The idea is what we're trying to find is you have these random plotted points, and you're trying to fit that data to a parabola of some sort. And I don't even know if the parabola opens up or down right now because all I have is data. But the calculator is going to figure that out for us, whether or not what the shape of the parabola is and everything, if it's skinny or wide or whatever. So we go over to stat. I'm sorry. First you quit to make sure you're in a blank screen. Then you go to stat, and then you arrow over to the calculate option, and you go down and you see it says quad reg for number 5. So I enter quad reg, and automatically, if you have a TI-84, I think some of the older ones you might have to put in list 1, list 2, but automatically it kind of assumes you're going to use the first 2 lists. So all you got to do is go down to the very bottom and hit calculate, and it figures out everything. So you see it says y equals ax squared plus bx plus c. That's the general form of a quadratic equation. And then it gives you your a, b, and c. R squared is something from statistics, just talking about how well this curve is fitting the data. We don't need to worry too much about that. A, b, and c are our concerns. So let's write that down. So we're on number 1, and I have 672.62, round off to 2 decimal places, x squared, minus 7863.0 1, 0, x plus 64071.43. Okay? So I wrote all that right here. You guys couldn't see that, sorry. Right, I wrote all that right there. Now, the problem is asking us to figure out what the we want to predict, right? That's I keep saying that in class, and I don't know if I say it too much or too little, but the point of math is really to build a model so that you can predict something, hopefully accurately. So now we're going to try to make a prediction about the population in the year 2000. All right. So find population in 2000. Okay. So what we can do is you can do this a few different ways. You can literally just say, well, this is my parabola, and I could say f of 2000, and I can plug it in 7, 6. This is probably the most straightforward way to do it. I don't know if it's the fastest way to do it, but probably the most straightforward. Times 2000. Oh, I'm sorry. See? Look at me. 2000, because remember we said when we entered these in 1, 2, 3, 4, 5, 6, 7, 1996 was year 7, so 2000 would be year 11. So my mistake. This should be 11. 11. 11. Okay, and then plus 6407.43. All right, and that'll get you. When you plug it all in, should get you 58964.00. So that's and the thing is, you'd have to go through it and do all the arithmetic, but you know how to do that. Okay, or you could, I think this is faster, go to y equals, and excuse me again. All right, so you go over to y equals. And I already have the equation put in the calculator, so you have it entered in there, and then you can just go to the table. If I hit second and then table, and I can look up year 11, and you see year 11 is 58964. So I didn't have to go through and actually compute everything, which was nice. So answer number 1 is A, and that's how you do it. Okay, number 2. So a farmer has a plot of land, has a fence, and then he wants to make a plot of land, one side of which is bordered by a river. So we have this fencing here, and we'll call these sides x and this side y. And this is the concept of optimization, where you want to make the most out of a limited supply, because the farmer is going to have his sheep or cattle or whatever, and they're going to be grazing, and he wants to give them the most area to graze with. So, okay, we know that the perimeter from the problem, it says, is 1,500 feet. 1,500 feet. So 1,500 is equal to 2x plus y. I'm sorry, the fencing. See, we don't use this side because there's no fencing. All right, and this means that y is equal to 2x minus, whoops, other way around. 1,500 minus 2x. All right. Now the area is what we're interested in. And the area of a rectangle is length times width, or length times width, however you look at it. So that's x times y. Okay, it makes sense to talk about this equation, but why am I even talking about the perimeter? The concept is that it's difficult to deal with a function that has multiple variables. So I use this relationship between x and y to solve for y, and then I plug this into here, so that way I can say, well, area is now, as a function of x, 1,500 minus 2x. So that's negative 2x squared if I distribute the x plus 1500x. And now this is a lot easier to talk about. You guys can already see this is a parabola that opens down, so it has a maximum. And to find the maximum, we learned that the maximum is going to come from x vertex is equal to negative b, here's my b, over 2a, and there's my a. So that's negative 1500 over negative 4, which turns out to be 375. Okay? So this is this side of the fencing. I could either plug this back into here, or I could say, well, what's y? Y is 1500 minus 2x. So y is 1500 minus 2 times 375. Well, that's 750. And then I just multiply these two numbers. Whoops, I don't know why I put parentheses, but so which gives me area equals x times y is equal to 750 times 375, which is 281250, 281250, which is A. Again, the other thing we could have done is plug this right back into here. We should have gotten the same number. I thought this might be the easier way conceptually to do it. So let me just check my answer here. Yeah, it's A. So that's how you do that. Okay. Another question, application of quadratic functions is projectile motion or a falling object of some sort. So like in number 5, I have a rock that is falling from a tower that's 352 feet high. So, and as it's falling, we're given the formula h is equal to negative 16t squared plus 352. I wrote it backwards because I like to have my t's in front. How many seconds will it take for the rock to hit the ground? And they even say h equals to 0. Well, if h is equal to 0, then I just write 0 here, negative 16t squared plus 352. See, and now what I'm hoping to do in this class is to make this part, everything from here down, automatic. So that way you guys don't have to think, oh, how do I solve this equation? Now you know how to solve this equation. I can use the quadratic formula, or I can complete the square. Or really, I could just move this over, and I can get negative 352 over negative 16 is equal to t squared. So t is going to be equal to the square root of 352 over 16. This one's really easy because there's only these two terms. Once you have the middle term, you have to do completing the square or quadratic formula. So this is the square root of 22, which is about 4.69 seconds. Or 4.7 seconds. So that's C. Okay? So those are easy. What I was trying to say earlier is that from here down should be fairly automatic. You know, they're either factor, complete the square, use a quadratic formula. The real world problems, the challenges is reading a paragraph and then saying, okay, how do I write that in math talk so that I can do the automatic part? Because that's what we want to get to. Okay. And then number 6, same idea, and it's helpful. A helpful skill when reading word problems is to kind of sift through all of the unnecessary stuff. Like me, I'm not even looking through. A rock is propelled upward from a building 100 feet tall. Blah 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 blah. This is all irrelevant information that the problem is giving you, and it's a good lesson to learn. You need to learn what's relevant, what's not, so you don't get overwhelmed. What's relevant is this. That's it. And then the question, of course. So they give you the equation, and so I write f of t is equal to negative 16t squared plus 136t plus 100. Okay, and it says determine the time at which the rock reaches its maximum height. We're looking at a parabola. That's what basically this test is about, is just parabolas and quadratics. So, well, it says determine the time at which it reaches the maximum height. When is that going to happen? Well, time is the independent variable, or the x-axis, and then height is the y-axis. So I know that if this was negative 16x squared plus 136x, then the x value of the vertex, which is the maximum, is going to be negative b over 2a. And the problem's done. So very conceptual, not a lot of computing. So negative 136 divided by negative 32 gives me 4.25, which is C. Okay? Alright, so there's more word problems, but a lot of them follow that same idea of just, the calculator problems are mostly the same. You use the quadratic regression option, so I can go down and get the quadratic regression, get my equation. Now, what I might do with the equation in different problems is different. Like in number 7, all it's asking for is the equation. So I go through here and I remember that, okay, I can literally enter through the years. Here, it tells you, though, you have to be careful, because here it says take 1900 as year 0. So when I go in and I enter my data in my lists, I would have to be careful to put in, 1950 really should be 50. 1960 should be 60, and so on and so forth. I can't just enter in anything, not in this problem, because I have to get the exact same equation. So that just comes down to reading the problem carefully. But I still am using the same features of the calculator, and then I'll end up getting my equation and circling my answer. It's just a matter of matching. They don't even want you to find anything with the equation. Just get the equation by putting the data in and going to quadratic regression, and then you're done. Okay, so there's those. Some of the newer stuff that we went over about solving equations of quadratic type and equations with radicals in them. I want to review that a little bit. So we have number 14, 3x plus 4 equals 2 plus the square root of x. A helpful rule of thumb: the number of radicals that I see tells me how many times I'm going to have to square the equation. If I see the number of terms with radicals, so I'm looking at 2 terms, 1, 2. So I'm going to have to get the radical by itself and then square it twice. I'm going to have to do that twice. So we square both sides right off the bat because I already have one of the radicals by itself. And I get 3x plus 4 equals 4 plus 4 times the square root of x plus x, if I combine like terms. Subtract 4 from both sides. Subtract x from both sides. So I end up with 2x equals 4 square root of x. Square both sides, because now I have the term with the radical by itself. It is not helpful to divide out that number. You want to leave that number right next to it. Leave the 4 right there, and just square both sides. So I have 4x squared, and then this gets squared and this gets squared. So this is going to go, the radical goes away, I get 16x. Alright, and then I move this over and I'll get 4x squared minus 16x equals 0. I factor out a 4x and I get x minus 4 equals 0. So I have two solutions, x equals 0 or 4. Now, remember that we don't know how many of these are going to work. So we have to go back and plug in. So I plug in, let's say x equals 0, and I get square root of 3 times 0 plus 4 equals 2 plus square root of 0. 3 times 0 plus 4. So if square root of 4 equals 2, well, that's true, because I'm not sure here if it's true. This is true. So this one works. This is a solution. X equals 4. So then I do the square root of 3 times 4 plus 4 equals 2 plus the square root of x. So this is going to be 12 plus 4. This is 16 square rooted is equal to 2 plus the square root of 4. So this is 4 is equal to 2 plus 2, which is obviously true. That's literally 2 and 2. So both solutions work. So my solutions are x equals 0 or 4. Final answer. And this one is a written problem, so I have to write x equals 0 or 4. I know I do a lot of multiple choice, but I'm starting to do some fully worked problems now. Okay, match the quadratic function to the correct graph. I think we should be pretty good at that by now. We know how to shift over. This is going to shift 3 to the right and up 2. And the 1/3 we don't worry too much about. If we have two graphs that actually have the vertex in the same spot, then we'd have to look at it. But let's just first pay attention to shifting over to the right by 3 and then up by 2. Okay, this one could be it. We know it's a parabola that's opening up because there's no negative. It can't be this one. All of these vertices are in the wrong spot. It has to be B. Which it is. Okay. Alright, these are old problems from the quiz that we already did a lot of. Write the quadratic function in standard form. I'm going to do one completing the square problem just to keep our memory fresh. Number 20. Y is equal to x squared plus 2x minus 3. So it says write the quadratic function in standard form. Y equals a times x minus h squared plus k. So I have to complete the square. And I only worry about the first two terms when completing the square. So this is my b, so I do b over 2 squared is equal to 2 over 2 squared is equal to 1 squared, which is 1. So I write it this way for a reason. I'm mainly looking at these last two numbers. So this gives me x squared plus 2x plus this number is the number I add, and then I take it away on the outside. Right? It's a coincidence that this is the same number. So usually in most problems these are different because you square it. This is always going to factor into x plus whatever this is. 1 squared minus negative 3 minus 1 is 4. So that's it. Done with that problem. And the answer is going to be B. It's going to be B. Number 20. Yeah. Okay. So what else we got? Number 26 is pretty quick. Square root of 4x minus 7 equals 5. I just square both sides and solve for x. So I square both sides, this goes away, this is 25. This is 4x minus 7, and then I'll get 4x is equal to 25 minus 7, plus 7 rather, is 32, so x is equal to 8. that might work. Again, with these radical problems, you have to plug the number back in every time. There's no other problems that in my memory that we have to do that with. There's from section 2.6, there's these problems where you have to do these substitutions. U is equal to x to some power. But you don't have to check your solutions with these. With these, you do every time because some of them don't work. Maybe none of them work. So we check and we say 4 times 8 minus 7 square root is equal to 5, allegedly. So this is square root of 32 minus 7 is equal to 5. So this is 25 square root is equal to 5, which is true. Okay, so that's the answer. X equals 8. All right. That's most of it. Okay. Yeah, this is the substitution stuff. So number 34 in the review packet. It says find all solutions to 2x to the 2/3 plus 3x to the 1/3 minus 2 equals 0. All right. Well, the trick here is that this is an equation of quadratic type. It doesn't look like a quadratic right away, but if I write it like this, 2 times x to the 1/3 squared plus 3x to the 1/3 minus 2 equals 0. Because remember that with exponents, when you're doing something like, let's say I have x squared to the 3rd, these two multiply. So I'm going to get x to the 6th. So that's what I'm doing here. I'm just kind of doing it backwards. I'm factoring the exponent if you want to think of it like that. And I notice that if let's call this thing x to the 1/3. Let u equal x to the 1/3. Then I just write, well, then this is 2u squared plus 3u minus 2 equals 0. And then I can solve this for u. And I can just use the quadratic formula. U is equal to -3 plus or minus the square root of 9 minus 4 times 4 times 2 times -2 all over 4 is equal to -3 plus or minus the square root of 8 and 2 is 16, and 9 is 25, so this is over 4. There was probably a way to factor this, but I didn't feel like thinking about it. All over 4. So this is -3 plus 5 is going to be 2 over 4, and the -3 minus 5 is -8 over 4. So this is 1/2 or -2. Those are my two options for u. So then I write u is equal to 1/2 or u is equal to -2. But what is u? I said that u was x to the 1/3. So then I just write x to the 1/3 is equal to 1/2 or x to the 1/3 is equal to -2. Because remember, we're solving for x, not u. This was a trick that we used, or a substitution that we made. So now to get x by itself, I just cube both sides, because that'll cancel the 1/3, and this gives me 1 over 8, or cubing both sides of this gives me x equals -8. So these are my two solutions here. And there's no need to go back and check for these problems. All right. Now, this is not the substitution that will work every time. You have to look at every problem that looks like it might be of quadratic type and then say, okay, what do I have to pick u to be? Because sometimes it might not be so obvious, and I'm looking for another one in the review packet that has done that. Yeah, okay. Number 42, last one in the review packet, says find all solutions to m squared minus m squared minus 4 times m squared minus m equals 12. Okay, and I won't work the whole thing out because it's the same idea, but this is a problem where you have to select your u correctly. And obviously doing this for your u is not going to help at all. What I want to do is I want to say, what is it that's being squared, and then to the first power, and then a constant. And that's this quantity right here. So that's what I call u. U is equal to m squared minus m. And then I get u squared minus 4m equals 12. And then if I move this over, I get u squared minus 4m minus 12 equals 0. So the factors of 12 that add up to 4, 6 and 2, u minus 6 times u plus 2 equals 0. So I get u is equal to 6, or u is equal to negative 2. And then I have to remember m squared minus m is what I made u, equals 6, or m squared minus m equals negative 2. And then I have to solve these two quadratic equations for m, and I'll get 2 solutions each, so I'll get a total of 4 solutions. But that's the idea behind those. So that's my best shot at trying to give you guys a good review of the chapter, and hopefully you've been studying hard. I'll see you guys tomorrow.